Hello, community. What's going on? Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I am Gerardo Lopez. Regularly, my colleagues and friends call me Falcon because it's my second last name. I am CNCF ambassador and Google developer expert in cloud technologies, and I will be your host today. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They will build teams, and why not break teams too, and they will answer your question. In today's session, I am stuck to introduce Jay and Yuri, who will be presenting on Crossplane 2.0 AI-driven control loop for platform engineering. This is official live stream of the CNCF, and as such is a subject to the CNCF code of conduct. Please don't add anything to chat or question that would be a violation of the code of conduct. Basically, please be respectful of all your fellow participants and presenters. With that, I am very glad it over to Jay and Yuri to kick off this presentation. Let me present to both Jay and Yuri, all of you. It is your place in order to show your case. I am here in order to help you, and right now I pass the ball to you guys.
Yeah, thanks so much. Let me kick this off. Let me start my presentation here. 1 second. And I know it takes a moment. There we go. Yeah, so as was mentioned, right, we're talking about AI, the advent, the changes that are happening in Crossplane, right? What is Crossplane? We're going to kind of go through and level set about some of the fundamentals. We're going to talk about the changes, and we're also going to talk about how we are envisioning AI as part of this whole structure. So again, right, my name is Jay. I am a staff solutions engineer at Upbound, and I'm joined by my dear friend and colleague, Yuri, who is a principal solutions architect. And we'll walk you through some of these things, including some really cool demos to show you. But let's start out with what's Crossplane, right? Not everybody knows, not everybody's familiar. So in a nutshell, it's a universal control plane. And what does that mean? A universal control plane in the sense that we want to control things like you are likely already using controllers that exist as primitives today in Kubernetes, like replica sets, right? We have a replica set of 3, we delete a pod, what happens? It comes back, of course. We want to do those same things with infra and anything else, right? We want a truly universal control plane. So there's 2 real superpowers, I think, that Crossplane has in that sense. One is that control plane, right? We have this permanently declarative control plane where we specify things that we want to build. They are there in perpetuity. We don't have to worry about them, right? The controllers take care of reconciliation, and they're in that way forever. The second, and equally as important, is being able to offer these golden paths as APIs. We want to serve things in a very simple way, right? What is the lowest common denominator? Generally speaking, thinking about hyperscalers, thinking about really any technology, it's an API. We want to serve those same APIs the same way that everyone else does, but we want to do that to enable self-service, developers, etc., right? To be able to consume these golden paths that we're creating. Some of the things that have been changing in Crossplane 2. So we've heard a bunch of feedback, right? We took all that feedback into consideration. And one of the hugest things I think most people talk about is namespace scoped resources. So we've taken these constructs that we typically had in the past, all these nouns, right, that you may know and love about Crossplane, composite resource definitions, compositions, composite resources, and everything is now namespaceable. So what does that mean? That means that originally, in order to make one of those API calls, those claims, that was our mechanism for namespace scoped resourcing. We don't need that anymore, right? So now we're simplifying this. We also have the capability to directly influence or directly control Kubernetes objects, right? Typically, you would have a provider for that, but now we can control them directly. And maybe more importantly for our conversation today was the advent of operations. And so operations, think of them as kind of like a day two ops. Things like scaling, upgrades, all sorts of interesting use cases can come from operations. There are two kinds of operations, really actually three. There are cron operations, so things that we can run, right? We can run these functions, these pipelines, these things we want done, upgrades, scaling, etc., based off of time. We can also do them based off of watch events. So we can watch Kubernetes events, and we can watch status, we can watch all sorts of things and make those things happen based off of those events. So more of an event-driven architecture. There's also one-offs. That's the third that's not mentioned here, right? We can just have, maybe there's a scenario we just need to do one thing. We need to do it once and we're done. We can do that as well. AI, right? How does AI fit into this whole thing? So, of course, we're all using AI in different capacities. Claude Code, Gemini, OpenAI. We've got all these things. We're leveraging them. We're trying to make these things safe. But realistically, right? I think if you've tried or even read anything about something like, we'll say, OpenClaw, right? That seems to be pretty hot right now. If you set OpenClaw loose, you are kind of at the will and mercy of your prompts and what the AI will decide to do. Most recently, I saw, right, someone deleted all their emails, all of them. They tried to stop it, right? But once the machine starts rolling, it's hard to stop without actually stopping the process. How does that relate to us, right? And two things. I think with Crossplane, of course, right? We're talking about building infrastructure, and that infrastructure doesn't matter. We don't care where it is. We don't care what it controls. That can be managing different GPUs across different hyperscalers, across smaller hyperscalers, across an on-prem hybrid cloud approach. But then secondly, maybe more importantly, is being able to utilize what we've built, those APIs, remember, to say, hey, right, we want to go create a thing. And being able to keep that agent on the rails, so to speak, right? Because we fed it a schema, because it can't hallucinate and go off the rails and create things that we have defined that it cannot do. It's an easy kind of low-hanging fruit to teach our agents how to use them. And then furthermore, right, what Yuri and I are demonstrating is kind of involving them in the reconciliation loop, letting them provide some of the logic and really kind of lowering the bar as far as the skill you need in order to let things like upgrades happen and scaling and all sorts of interesting things. Just some links, right? We wanted to provide some links for everyone, right? If you want to dig further down this path, of course, the link on the left is going to show you some of the advent of what Crossplane and how we think about how it impacts things moving into the future with AI. And then we'd love to have you on our community Slack, right? Crossplane Slack, and then the community page there if you are interested. And on that, I will hop into my demo. One moment. Okay, so my demonstration today is around the idea of being able to create a Kubernetes controller, but using Crossplane and operations with AI. So what we've done is created a watch operation. So let me show you that watch operation. It's called replicas. So some of the things that are in here are pretty benign, we'll say, right? We have an input. So I'm passing an input to a function. The function is OpenAI. Now, actually under the hood, since OpenAI's APIs are pretty standardized and we can use them with things like Ollama, this is actually calling a local agent on my machine. So I'm actually calling, I think the model is GPT OSS 20 billion parameter model. Very small, right? It's not doing a lot of work, so we don't need anything really fancy, nor do we need to spend money. So I have a basic prompt, right? I have a Kubernetes, you are a Kubernetes controller. I want you to watch all the deployments in my namespace default, and if any of them fall out of a replica set of 3, I want you to correct that. And so right here is the prompt. Here is the actual watch. So I'm watching deployments, watching them in namespace default. Right now, I don't have any pods running in the default namespace for this, right? Just a one-off configuration of the registry that was run. And so now I'm going to actually apply this and see what happens. So I'm going to apply, let me show you actually briefly the deployment, right? Nothing special, very simple Nginx deployment with a replica set to 1. So let's apply that. Great. Let's get the pods in that namespace. Right now we just see the 1. We should see some operations kicking off. Because that watch operation should be triggered, and it was, we have operations that are kicking off. So these operations are the actual things in the pipeline that's being run to reconcile against what's happening. So it should take a couple of seconds. Again, remembering I'm not using one of the big guys, right? This is not calling out to OpenAI. This is just calling my local Olama. So it's a little slower than the typical response would be. It looks like we got succeeded on 1. So it looks like one of the events is run, and we have a replica set of 3. We can even dig into the deployment, right? And see that replicas is set to 3. Now, realistically, outside of this scenario, what does this show, right? We are very simply creating a controller. Now, controller in the traditional sense, no, of course not, right? Like this is not a true Kubernetes controller. But now you can start ideating on what is possible, right? Maybe this is something that also includes some of the knowledge that exists inside of whatever industry, right? Some of that tribal knowledge that exists inside that maybe others don't know. It could be things along the lines of, well, it's no change Friday, right? If someone's trying to do this on Friday, disallow. This could have some of that knowledge around scaling and right. Maybe if you're someone that handles Black Friday events, right, and some of the institutional knowledge that came with previous experience in that, this could wrap into that as well. So on that note, I think that's a good segue to pass it off to Yuri. Yuri has a demonstration that is more on point, right, with the kind of advent of maybe that Black Friday event, right, and scaling those things. Take it away, Yuri.
All right, thank you so much, Jay, and hello everybody. I'm Yuri from Augment, and I would like to show you some AI autoscaling demo of the database end-to-end, building on the same primitives that Jay just introduced us to. So hopefully my screen is visible. If it's not, please interrupt me right away. The reference platform is available open source style at Augment.org, configuration AWS database AI. And the overall principle, we will be building on top of standard declarative mode of the Crossplane, right? We will run RDS instance with a relatively straightforward composition, and we will use a function RDS metrics that will enable the self-evaluation of the instance. It will basically publish its own performance metrics via the AWS CloudWatch, and we will have a cron operation, AI enabled. We will use function cloud that will react to this performance data, and we will use the prompt to control this behavior, to control the autoscaling. So how this thing work, I am about to show you end-to-end. A little bit of context here. So we are running this SQL instance, right? It's nothing special from the perspective of a composition. So it's really minimalistic instance, subnet group and secret, and it is instantiated from this spec. If you compose a SQL instance with Crossplane before, it will be all familiar. to you. What is special here, if we look at the SQL instance spec, we will see some interesting things that are happening. So this is our SQL instance. Performance metrics are already available and published under the performance metrics field with the all CPU, database connection, utilization, memory, etc. And there is some intelligent scaling AI-based decisions that are made on schedule, currently every minute. So what I'm going to do now, I'm going to run a performance test over this database and with attempt to invoke autoscaling event. So currently it's under Calm, under utilization, and in a parallel terminal, I'm running this demo scripts that will just retrieve the metrics and special annotations in a concise view. That's it. It's exactly the same YAML, just filtered. So what we are going to run now is a special performance script, and we will attack this database with a tool with a nice descriptive name of MySQL lab. So I found that this tool is pretty effective to stress test the databases, and looks like it's already in action. We'll double check that slab is slapping. Looks about right. And so the idea here is that we are going to stress test the database, attack with this load, and invoke this auto-scaling trigger. In the meantime, how all this stuff is actually composed and working, right? So we can look at the composition of this SQL instance. So apart from the standard composition function itself, we are going to use this function RDS metrics, and it is also available in open source in a bound repo, open source style. That's the function input, right? So we are collecting some data and we publish into status performance metrics. So it's a no AI involved. It's a just deterministic function that is responsible for these metrics collections that we already seen before. That is published to the status of this SQL instance abstraction. Now, what is actually setting this intelligent scaling annotation and how? So as a part of this control plane, we have operations, this concept that Jay mentioned in the beginning of presentation. And we are running cron operation. In a demo mode, we are running it every minute. And the idea here is that we will tell our AI system to act as intelligent RDS autoscaler, and we'll use this pretty battle-tested prompt, a little bit deterministic intentionally. So we define scaling triggers, we define the behavior, we say it what to do regarding the scale progression, so how to scale it like given the load from micro to small to medium. And eventually we tell it to patch in case of scaling is required. We telling it to patch the instance class of the parameters, so just to auto-scale by instance type. If scaling is not required, we tell it to set the special annotation, so we can track the operation and how it actually behaves right now. So let's monitor how our stress load is going. Currently, we can see that there is a slight peak at 14%. Usually it takes like, around 5-7 minutes to scale up to 60%. I will just double check that my slab is slapping. Okay, that's good. So eventually the load should come back to us. In the meantime, we can investigate the prompt a little bit closer. So now, as we can see, that we are basically patching the SQL instance under evaluation, and we have also some constraint how to what to put into this last analyzed and last scale decision annotations, and we have SQL instance resource as a part of the prompt, right? So how are we getting it? So that's a very convenient integration from Crossplane. As a part of operation, we have ability to include this required resource, and in this case, we are including resource of kind SQL instance of this API version, and with a label, match label selector of scale me, right? So pretty straightforward. So that's how our current instance is getting into this AI evaluation loop. What else to mention while we're getting more load? Yeah, 40%. We are pretty close. We running this as a cron operation, as a higher level operation, right? So that's the spec of what I just showed you in the editor. And the cron operation every minute is invoking the fine grained operation. So it's like these one-shot operations, kind of Kubernetes job style things, but what is invoked is a function cloud within. And we can get the operation and get the latest one, for example, and ask for the YAML output and see what happens there, right? So it's this our prompt, and it's overall succeeded. Same style, we can describe this operation and see the event stream. So in the event stream, we see the latest scale decision. You already can observe that the decision actually was made even when auto scaling is not yet required. So we are pretty close to the threshold. And the AI already reasons. So reasons about the need of auto scaling. So currently it's appropriately sized at the initial db.t3.micro instance type. So pretty soon, yeah, we already reached the threshold, and through a CloudWatch, these data will be evaluated by AI. So it's already propagated by CloudWatch in a status, so it's already pretty cool, 91%, and very soon we can expect a trigger event, and actually it already happened while I was talking. So scale up required, CPU utilization 71%, instance upgraded from DB T3 micro to DB T3 small. So that's exactly expected result, as AI has made decision according to the scale instance class scale progression, right? And just to double check that it did its job, we can check the instance spec, and it was already scaled up from micro to small. So that stuff is working, and now as it in pretty high utilization, is going to monitor it, and depending on the load situation, it's either going to scale it further up to the progression. We already see it, right? So DB T3 small up to medium, but it's not going to auto scale right now, because we currently we in a cooldown period to to avoid this flipping continuously every minute. So it has its own self-control mechanisms that are also part of the prompt. So you can really build up, as Jay mentioned, this controller in a plain English, and describe the scaling triggers, the cooldown thresholds, and build a pretty reliable scaling system that reacts to different state of the control plane and associated API. And as you can see, the main core of operation still stay declarative. The RDS instance is still standard Kubernetes composition, set of composed resources, plus some data for evaluation of the API. and we just injected just enough AI for the autoscaling, right? The core of the control plane is still deterministic, declarative, and predictable. So that's the main goal, like combine both of best from both worlds, right? Maybe a little bit on implementation. I didn't use a local model like Jay. I used the function cloud here with a HICO model name, which is relatively cheap, much cheaper than Sonnet, and more than enough for the simple evaluation like autoscaling. Function cloud is also available in our GitHub. So that's, I guess, pretty much for the demo. Let's check the latest page, scale up pending. It's still under load. Our AI autoscaler will take care of the autoscaling events, and actually, eventually, if we wait for a while, when the load gets down, it will also downscale according to the progression. So this progression is actually bidirectional, as we mentioned. So this stuff works end to end. Check it out online. Everything is open source. Play with it, clone it, give us feedback. Thank you so much.
Thank you, guys. So there is a question right now. The question is, in your demo and production environments, are you running the community Crossplane distribution and community providers or augment official builds?
Yeah, so in our demos, realistically, that it is truly agnostic, right? What we're showing you is actually in mine is not running a provider at all. I'm just running function OpenAI, right? There's no providers. I'm not actually configuring infrastructure in any way. These things all run from Crossplane OSS. For Yuri, right? He's using outbound providers, but he is using the community version of those providers, right? So, as you may or may not know, there's a demarcation between Upbound's community and Upbound enterprise. So we are using community versions for our demonstrations today.
So everything that was shown is upstream compatible, exactly as Jay mentioned.
Nice. Well, the question is, do you find LLM-based scaling to be reliable, or would it make more sense to use LLMs to generate deterministic scaling rules that can be reviewed?
Yeah, I mean, with any AI, right, there's always the element of possible non-deterministic outcomes, realistically. So we prompt the best we can. We use the most appropriate models for the jobs, and we get a really good output, right? Like what Yuri and I just did, we just used models, right, with our prompts. It could have hallucinated. It could have done something insane, but realistically, it has never done that for me. I cannot speak for Yuri, but right, it's just about using the right tools for the right jobs. And so I think it's more appropriate to talk about these things in the idea that AI is a great tool when leveraged appropriately. So if there are deterministic outcomes that can be done simply, then maybe do it that way, right? But if it's my thought is that if it starts to encompass that internal knowledge, right, to be able to actually use internal knowledge and to scrape against those things and to have knowledge about how your organization does things, that starts to change the conversation a bit, right? That allows a bit more of a dynamic output to be more realistic. Hopefully that answered the question. Yuri, do you have anything to add?
Yeah, I actually get this question on determinism a lot, and definitely, like, if you need a 100% deterministic version of what was shown, you can convert this English style, plain English controller into composition function, right? And leave to AI more like a non-deterministic stuff, like author systems, like whatever we can judge, like on cost, on something that is not organically can be put into Kubernetes controller. But I think we can find a good balance here between the deterministic part and a fully like AA enabled one. So it's always like specific to the case.
Okay, people continue asking. It's so good. It means that the people like your content, guys.
Yeah.
Here's another question about Juan David Arguello Plata. As a Chrome operation, it could be expected to consume tokens every time it
Right.
is executed. For certain operation, it could become quite expensive. It could make more sense to trigger autoscaling using metrics like Prometheus, Alert Manager. Does Crossplane has any support or mechanism to trigger this pipeline based on metrics and thresholds?
Yes, it will consume tokens, right? The first things that I'm thinking about right now is a watch operation version of this operation trigger, right? So instead of cron based, we can watch some object changing and then trigger only on that in this case. Then we basically can hook in this any kind of operation that will be invoked only according to the specific event.
Yeah, adding on that, right? That's part of the purpose of why I even showed the local capability, because I think in the context of a large enterprise, we're finding that as larger LLM and inference providers exist, there's a need for data sovereignty, right? And nobody necessarily wants to be passing those things out into somebody else's API. So I think realistically, a lot of these things can be driven by some very small localized models running in parallel, right? In that way, you have that data sovereignty, you have that repeatability, you don't have to worry so much about token use because they are such simple outcomes in most scenarios.
And by the way, I ran something like a cost evaluation. It's a part of the repo, right? So the haiku with every cron operation each minute, like aggressive demo mode, then it will take around $10 a day for the single for this kind of style of operation run. Definitely, you can relax the schedule, and it will be cheaper. You definitely don't want to use Sonnet for that. I learned it hard way at KubeCon, wasting $700. So you definitely have to be careful there.
Yeah, sounds good. It is other question right now. William Quiroz, thanks for sharing this, Yuri J. It is really powerful to use functions and Chrome operation to drive autoscaling actions. What other use cases do you recommend for LLM functions?
Gosh, sky's the limit, right? So like I mentioned before, part of the reason for operations as a whole was for things like scaling, for upgrades, for, right, all of these kind of like day two type of operations. But, right, as I showed you, you can break that mold. You can do a lot. So what else could you do with an LLM? Like I keep, I said it probably 6 times. I'll say it one more time, and I'm sorry. Injecting institutional knowledge is going to be huge, right? Knowing how your organization works with it is going to be huge. So being able to do something like I'll use the Black Friday analogy again, right? If the institutional knowledge is that we know we need to scale these DBs and these things and that at this time based on this type of load, right? We've already gone through and done the analysis, and now we just kind of want to set something on an autopilot. I think that's a huge use case. And building in, whether that's integrating something like a skill or having an MCP in order to have some of that knowledge integrated, or even building from scratch, right? Like there's a lot of things to do, and I know that's kind of an ambiguous answer, but it really is like just so many things.
Yeah, like imagine this autoscaler with internal company knowledge of running run books and how to react to PagerDuty and all that stuff, what Jay mentioned, right? So like inject this knowledge to the context, and now it's suddenly much more powerful autoscaler with that can act as an SRE, right?
Yeah, well, it's not a question, but I think so. It's a good comment. It says, mentioning the local model is a thing. Glad you mentioned it. Also, for how enterprise can fine tune. Plus, it's cheaper token wise. What do you think, guys?
Yeah, 100%. So I get made fun of a lot because I'm a huge hardware guy. I'm an on-prem guy, right? That's where I cut my teeth. That's where I started. I always joke that I didn't see the cloud until I was a man, right? The kind of a Bane joke there. But I agree wholeheartedly that, and I see that quite frequently in large enterprise, right? We don't want to send our data anywhere. They never did. They never, right? Like AI doesn't change that model. It's just now we need to start thinking about how we're going to consume things and what's going to run inference and what engines we're going to use and how concurrency will work and the KV cache size, right? We can start going down this like inference rabbit hole. But it all comes back to data sovereignty, token costs, and realistically, like the comfortability of the organization with using things that will egress, right, to either Claude Code, Gemini, or Copilot or whatever, right? There's a little give and take there. So I think that that it's 100% the large enterprise direction, personally.
Yeah, sounds good. I think so. No more questions yet. I don't know, guys, if you want to add something to the people. What the next step? I know that you expose and you show different QR codes, but I know if the community are more interested about that, what is the next step that you can recommend them?
Yeah, 100%. So, of course, right, check out our repositories. Check out Yuri's. You can copy, you can do whatever you want with it, amend it as you wish. Check out mine. Do the same thing, right? Change it from deployments, do something with services, do something with whatever you want, right? All of it is out in the open. Do feel free to play with it. Give us feedback. Tell us how it went. Tell us how it didn't work. Tell us how it did work, right? Tell us what you're doing with it, because there's so many things that are possible now, right? Outside of just managing infra and managing GPU workloads and managing all of these things. Like there's just with operations and functions that are doing things, calling LLM and doing inference. There's so many interesting things, but I digress. There's the links back again on the page here. You can access this deck. So, you can have in that top right-hand corner. That way you have access to the things we talked about today. Again, there's the Enterprise Platform Engineering document written by Upbound in the bottom left. And we'd always love to see you in the Crossplane Slack in the community, right? Yuri and I are constantly in there doing what we can, helping out. And yeah, just be nice to have you.
Nice. Amazing, guys. I learned a lot. I know that the community learned a lot too, because it's an amazing topic. I know that probably we can constantly talking about that and learning more. Thank you so much for your time. Excellent speakers. I learned a lot, again, I want to say. So thanks, everyone, for joining to this latest episode of Cloud Native Live. We enjoyed the interaction and question from the audience, of course. Thank you again for joining today, and we hope to see you again soon. Yuri, Jay,
thank you so much.
Thank you.